Welcome to the Unveiling Precision webinar. We're going to go over some scan data, office prep, and feature extraction today. Speaking today, yours truly, Greg Larson out of the Wisconsin office, and then I'm going to be speaking for about the first half on all things TBC and point clouds. And then on the second half of this, Mark Schnesk in our St. Louis office will be speaking about all things Autodesk today.
Hello, hello.
All right, today's goals, basically the big one is how do we get usable data from massive point cloud data sets? Today is going to be a high level view. We just don't have a lot of time to show you everything. So we're encouraging you to kind of let us know what you want to see as maybe a deeper dive in the future. But when we collect all of this data, there's about 5 or 6 things that typically happen in most workflows. And that's import, register, extract, create, and export. And as we go along today, please feel free to enter questions into the chat, and we'll probably answer most of those at the end of the webinar today. So just in background, our Kentucky team put together a comparative analysis of the current Trimble scanners. They scanned a historic house in Lexington, Kentucky. It was kind of a use case scenario of historic preservation and monitoring. In the white paper, you're going to see the mainline specs for all of those scanners there, the Trimble SX12, which basically works on a survey workflow for its data collection and registration. So the errors you see on your stationing are probably going to show up in your registering. And then there are 3 mainline production scanners, the X7, X9, and X12. You'll see these specs in the white paper that was created. And this is kind of the main analysis of that document. It compares the SX12 with the other 3 scanners, and you can see that the X9 there is kind of probably the sweet spot of efficiency in this portfolio. Took the shortest amount of time to do the 15 scans, and probably gave one of the higher among the quality, I guess, of data. So once we have that data, now I'm going to be talking about Trimble Business Center. As we import these massive data sets into TBC, it is kind of a challenge to keep all those files together. And this goes for the X series scanners as well. There's a ton of files that come along with an export out of those systems. You want to be careful about keeping this all intact, but Trimble has made it much easier for the SX12 lately through the Trimble Connected Workspace. And if you kind of start paying attention over the next 6 months, we might see some things for the other scanners as well. So we'll get through that. That's the file structure there. But the TBC Connected Workspace is right in the TBC Home ribbon. It was introduced in 2023 and further enhanced in TBC 2024. So as long as you're part of a Trimble Connect project, you'll be able to access that data through the Connected Workspace, which you see there. I was invited to this project by our Kentucky team, which is that Miller project there. And there were 2 jobs, the GNSS job and then the SX12 job. You can see the pertinent information right here, the coordinate system information and what's in the job. Go ahead and import that. And as the stuff comes into Trimble Business Center, we can turn on the background maps and make sure things are coming into the right spot. And then for the SX12 data, we can go back to the Connected Workspace there and go to that same project, and then you can download. As we click on the SX12 project, you can see that it's actually not really in a coordinate system, but there's the number of scans and images and points, and we can go ahead and import that. And through the magic of webinar editing here, everything is all where it needs to be in a geo-referenced environment. So there's the survey data and there's the scan data. SX12, or I'm sorry, X7, X9, X12 data, fairly similar organization. Just drag that TDX into Trimble Business Center. But then TBC also has many different point cloud formats that it supports. So you don't have to use these scanners that were in the comparative analysis. Again, drone scans, the third-party scanners, like GeoSlam or something. Those will come right into TBC as well. And that's kind of what this is showing here, is we can get many different types of data into Trimble Business Center. The drone data you see here was actually processed in the TBC photogrammetry module. Most of this data is SX12. There's actually GeoSlam data in this slide. So it was all processed in TBC and in GeoReference. So we can really get a lot of different types of data together in a single software package. So once the data is in there, we've got to get it registered. TBC's got all the usual tools, cloud to cloud, automatic, pair registration, plane registration, and georeferencing. So that's going to be up in the point called ribbon, register scans right there. And the SX12 data as it comes in is georeferenced if you choose to make it that way in the Access data collector, or we can move it to the GNSS points through the normal TBC survey functions like transform or move or whatever you typically would use. I think the SX12 data when it comes to georeferencing is a bit more dependable and repeatable. You really can think of SX12 scans as control scans, much like you would with control points. It's very easy to anchor, the X series data to it. Although Perspective does have, which is the software that runs these scanners, there is georeferencing in there as well. And then the cloud to cloud, I watch your cloud to cloud results. Sometimes, it's almost like an easy button at times, and you can slam data together that maybe shouldn't be together, like especially in a monitoring or a deformation survey, and there you might want to switch to georeferencing. But here's just kind of a quick picture of the cloud to cloud. You pick points over here in the SX12 data, which is the reference station. The X7, X9, X12 data would be a moving station. You pick the corresponding point pair over here. You can automatically register. Here's the point pairs, and there's your results down here with your residuals and overlap. So probably a topic for another webinar. So we'd probably spend the whole hour on that if we wanted to. With this data set, did really well with georeferencing. The nice thing about the georeferencing, again, it's in the point cloud ribbon. Georeference, you can move scans that aren't registered or georeferenced to survey control points. What I like about the georeferencing tool is I see my residual errors after I move the scans. And TBC, I'm going to leave this note here. We'll be recording this, so you can read that note. But this is directly out of the TBC correspondence. So TBC does a little bit better job of georeferencing than the Perspective software does. So if you're seeing errors, I would certainly try it out in TBC. But here's the georeferencing here. X9 data on the left, SX12 data on the right. And there's our control point 101 there. And basically just click on it. Click on the corresponding part of the X9 scan. And that's what I like about TBCs. We can kind of stack these views next to each other in a vertical configuration. I'm adjusting the point size there. And there's that point pair. I'm gonna kind of speed this up a little bit. There are so we did 3 point pairs, and there are the residuals. Again, I like to see those. Usually I take a screenshot when I'm done, but there's the final result, all the data connected together. So after we do that, after you register, you want to probably do some quality control. One way to do that is to use TBC cutting planes, which are just cross-sectional views. They can be vertical, horizontal, even skewed, depending on what you want to see. But the nice thing in this project was we can take a kind of a top-down slice or top-down view of the foundation, or I'm sorry, the walls. And here's where if you have registration errors, here's where you'd probably see them, or you can see the degree of error that you might have between some of the scans. So I'm toggling off the SX12 scans right now, and you can see the results of the registration there. And you can go around and kind of evaluate everything as you need to. We'll move on there. After you've gone through that, you do have refinement reports, which are part of TBC. I know the field software has them for Perspective as well, but you can do them in here as well. So just part of your quality control process. And there's limit boxes, which are, there's a lot of software that has limit boxes out there, but if you need to isolate a part of the point cloud, you've got that option here as well. And as we kind of move through our project, now we're going to start to organize this point cloud. We've kind of maybe sliced it up a little bit, but really what we want to do is separate into its major components. And TBC does a nice job of that with the Classify Point Cloud tool, which is automatic, and then the manual tools are next to that in the Point Cloud ribbon. They did improve the automatic classification in TBC 5.9, and you can see the differences between the older version and the newer version, and it's actually improved since 5.9 as well. I've noticed that it does every version it seems like it does a little bit better job of separating objects that are almost merged together in a point cloud, like that sign was in the tree originally there. So we'll just show you quick here. The automatic classification is actually up there. You probably do want to switch to region color. And there it is there. It's basically a couple of clicks. This is the Classify Point Cloud tool. You just hit classify. And then you could refine as well. So if you're not quite getting everything. So there's the classifications, and the regions will show up over here after you're done. And again, it's not perfect. If I skip to the end of the video here, there's a tree that got stuck on the building layer or region. And you just basically, nice thing about having regions now is we can turn them off like layers and identify things that aren't where they should be. And you can go ahead and use the manual tools like I'm doing with the tree here, adding that to the high vegetation. We'll move on. So once we've organized our point cloud into regions, what that does is allow you to start turning on some of the feature extraction tools. And one of the newer ones is advanced filtering. This is kind of meant for the ground. As you'll see in the next couple of slides, when we try and create a surface of the ground, typically with a point cloud, we've got to sample it down so we get a smoother surface. If we try and create a surface without sampling the point cloud down, you're going to get a very rough surface with rough contours that aren't really usable. The advanced filtering tool lets you set dynamic cells, and basically it's like this driveway here. It looks for stuff like that, depending on the parameters you set. And we can filter the cloud down, but keep some of the features. So if we look here, here's a raw unfiltered surface, which, this is what happens if you don't do anything, any sampling. We can refine that surface or that ground region, but you can see that the contours are very jagged. If in the past we'd sample down, maybe sample down to a 5 foot, 3 foot interval, but we lose that feature. It's a driveway or a path. But here it's kind of a nice compromise with the advanced filtering, as we still retain that driveway if we need to. And then it can be part of the surface. If we collected polylines with the data, like the SX12 in the field, we could use those and add them in here as well. I'm going to switch over to a different data set for point extraction real quick. The trees in the Kentucky data set were kind of smashed together, so they didn't auto extract very well. I'm actually sitting right about here right now. But this is the TBC has automatic extraction. So for trees, poles or light poles, manholes and stuff like that, we can enter in a feature code here. So that's a broadleaf tree. It could be whatever it needs to be depending on your feature codes. And as we go through the process, we define that. We define the attributes, like for a tree, it would have spread, trunk diameter, tree height, stuff like that. And as we get through the process, I'm just going to speed through it here. You can evaluate each tree that it sees if you'd like, and modify the attributes as you go, or the codes. You can change the codes too. So if you got a pine tree or an oak tree or something like that, you can do those codes as you go. But the end result, once you hit the easy button at the end, go ahead and add all those trees. And again, if your FXL, your feature code library, has the CAD blocks are going to pop in there. And again, this is the same for light poles and any type of point feature that you want to do, manholes. So that's the point extraction. And then there's also automatic line extraction. One of the popular ones being the curb and gutter extraction. And we'll kind of hit the highlights of this tool right now. It's up in the point cloud ribbon under the extraction section there in the middle, right there. And we're going to go ahead and speed through it a little bit in the interest of time. What it does is it creates a miniature cutting plane as part of the tool, so we're not having to go out to the cutting plane tool. There's a little bit of a point cloud issue in that one, but we got rid of it. But we create nodes for the major nodes of the curb and gutter. So edge of pavement, the flow line, top of curb, back of curb, whatever you need to specify there. But we'll go ahead and pick those nodes just by clicking on the screen. And then as you go along, then TBC uses that miniature cross section that you've created, and it, and again, it depends on the data that's there. So if you are going to scan a curb or use this for a curb and gutter, make sure you scan all of it. As you can see there, I kind of missed some of that. So the tool does stop, and then you can manually edit after the fact. But then you can switch direction and keep on going. And there it goes the other way. And then at the end of it, there's the lines it creates. And we can edit those lines that, those are the best fit lines, smooths it out, smooth curve. And then once these lines are created, we can export those out to CAD. Same thing, another line extraction tool, overhead lines. And then once these lines are created, there are tools up in the point cloud ribbon for like line clearance to the ground and stuff like that, and automatically calculate it. But there it is again. So if you're doing a lot of power line work, you can get those scanned thoroughly, get those lines scanned, and the TBC will pull those out of the point cloud. And same for lane lines. Probably uses the color coded intensity settings, and the tool lets you kind of go up or down with that, but it basically detects the road markings, and we can do solid, double, single lines. You can put the endpoints on there. We've got manual tools, just like the curb and gutter, but there's the lines and points it creates. And then again, you can define a first and second dash for dash lines, and it does the dash lines as well. And I'm just going to skip over extract geometry. Manhole extraction, again, it's kind of the same as the trees. It finds them all. You've got your code, and it'll put the block in there. Sorry, I'm running out of time here, so I'm kind of speeding through it. Stockpile extractions in there as well. So if you're flying with drones or you were scanning with your X7 or SX12, you can pull those stockpiles out automatically. The extract stockpile tool is up in the point cloud ribbon as well. You can define all your stockpiles just by clicking on them, and it actually will auto extract the boundary. And then it'll actually, it compiles them, and then you can do it calculates the areas, the slopes, and the volumes. And at the end of it, you get a nice stockpile report. And speaking of reporting, back to the Kentucky data set here, we can do scan inspections. So I know that one of the concepts behind the analysis was deformation monitoring. So I kind of had to fudge this because all this data was collected on the same day. But if you, say you're monitoring over months at a time, you can compare those scans to each other using a scan-to-scan option. Or if you've got a BIM model, you can also scan to a 3D object and compare scans to 3D objects. But the process, basically, we define the areas that we're looking at, and then we can pick inspection points. And then that actually will print out a nice report with the view. And again, we're only touching the surface today here. There's much more, but we get to our deliverables portion here. We're exporting out CAD line work. I think what I sent Mark yesterday was an E57 of the building. Again, we can process point clouds and send those out in multiple formats. I didn't even talk about photogrammetry today. That's all in there. And there's lots more. So I'm going to turn it over to Mark. There's my email and our toll-free number for support.
I'm going to talk about similar things that Greg talked about. This is going to be using LiDAR scan data with Autodesk ReCap and the Autodesk products, specifically AutoCAD Civil 3D and Autodesk Revit. So I'm going to kind of take this from a position of getting data from TBC that has been processed, but I'm also going to go over some items that we can do in ReCap, especially the new versions of ReCap Pro that we weren't able to do before if we don't have those resources like the TBC classification tool. So the next slide. In this session then, we're going to talk about an introduction to Autodesk ReCap Pro. We're going to talk about importing and editing in ReCap, using it with the Autodesk Construction Cloud, which is the cloud-based system similar to what you would get with Trimble Connect, Autodesk Civil 3D and AutoCAD, as well as a little bit of Autodesk Revit. Not being a Revit guy, I kind of played around with that a little bit. So let's talk about Autodesk ReCap Pro. What is it? So it is utilize high quality scan and mesh data with other Autodesk products to help create detailed models of real world assets, scan data or photogrammetry, as well as bringing in 3D models. It is part of the AEC collection. So if you have the Autodesk AEC collection, which includes Civil 3D Revit, as among other 30-something other tools, you'll have access to Autodesk ReCap Pro. There is a free version that's just AutoCAD Desk ReCap Basic, which can do a majority of point cloud transformation, manipulation, and importation, but you're going to be missing out on some of the extra tools that I'm going to show in this presentation. We can share data with the Autodesk Construction Cloud, so we're now able to take that scan data, send it to our Autodesk Docs or Construction Cloud, or we used to be called BIM 360 web-based services for project collaboration with other shareholders, other stakeholders, other survey firms or engineering firms, as well as intra-office. And we can use that Autodesk Construction Cloud to extract point and feature data from Point Cloud. All right, so I'm going to go over importing data. So ReCap can import LAS, LAZ, E57 directly into ReCap. You can do auto or manual registration. So if I did have just E57s that weren't structured or weren't registered, it will do automatic matching. I can also export structured, non-structured E57 or ReCap RCP directly from Trimble Business Center. So TBC, besides the E57, you can export out RCP files, and I can just drag and drop those in the program directly. All right, so I'm going to have a little video here, data into ReCap. So if you haven't used ReCap Pro before, you're going to go ahead and start a new project and import that point cloud. You're going to give that a name. This becomes the name of the file. It's also going to create a support folder of the same name. It's important if you're sharing this data amongst other offices that you not only give the RCP file, but you give the shared folder as well. We're going to select the files to import. So in this case, I'm going to bring in this LAS instead of the E57, but you see you have quite a few different formats you can bring in. And then we're going to go ahead. You can then clip this data by intensity value. So if you want to get rid of like the lower 10%, which may or may not be accurate, you can slide this slider. We can also decimate by grid. So bringing it in up to 100 millimeters is about 4-inch by 4-inch grid. And if your geo-reference point cloud has a coordinate system you need to transform, I can use any of the 1,000 coordinate systems worldwide in the system to transform it. But if it's in one system, you're going to keep it there. There's no need to set that. So we let that convert that over from the LAS to an RCS file, and then we go into our data. We can navigate with the mouse, use your middle mouse wheel to zoom around. We can see that same point cloud data as we would have seen in TBC or LAS. All right, so visualization and editing. We can also visualize these point clouds in a variety of different styles, including elevation, intensity, RGP. Points can be selected and deleted or classified in the standard ASPRS classifications. And we can also do automated ground classification and model decimation tools, similar to what Greg just showed in Trimble Business Center. All right, a little video here. So in this one, we're going to talk about the visualization and editing. We could view this in an elevation mode. We can also look other modes in here. You can see intensity values, which is where I like to do my data extraction in. Scan location if I have multiple, and the standard ASPRS classifications. We can add some shaded lighting in there to help us visualize items. We have standard limit box, similar to what you saw in TBC, where we can make it easier for us to select and edit. So I'm going to go ahead, and we have this brace here that's on the tree classification. I'm going to go ahead and limit what we see here to make it easier for me to select those points. I'm just going to go ahead and draw a rectangular selection. We can also have polygon selection and assign it to that building class 6. Once we're done, we'll go ahead and clear that limit box, and it makes it easiest for it to go ahead and manually classify those objects. ReCap is very what you see is what you get. So if I draw a clip around this to limit the amount of points, if I wanted to make my model a bit smaller, if I was to go ahead and export what I see here, I would get a brand new ReCap file that shows exactly what we see here as well. There is an automated ground classification tool. I'm going to pause the video there for a moment. There is an automatic classification tool that you can pull down. If I was to get a raw data file and run it through there, it would basically classify my point cloud out. It uses a statistical classification to bring out ground, I'm putting air quotes up, from not ground points, and then I'm able to go ahead and decimate those out. Similar to what Greg showed with the decimation tool in TBC, ReCap Pro does have a decimation tool. So if I didn't want to, let's go ahead and play on there. There we go. Oh, I gotta start at the beginning here. There we go. So there's the automatic ground classification. I just choose the detail, the amount of decimation or amount of ground classification I wanted. There's also the decimation point tool, where it comes from the ground. It'll take those points and put it in class 8, the model key points. I can slide the slider by percentage, or out of my 16 million points, I could decide, hey, I only want to see about 16,000 points and decimate them that way. It's going to scatter them in a similar fashion, where it's going to throw extra points where it sees ridges and breaks. Here I'll go ahead and go to my layer list, and I will turn off the classification. So just like the layer system for the regions in TBC, I can show only what I want to see. Again, being a WYSIWYG program, you can barely see it there, but there are some points on that model. When I stop, they'll show up a little bit. I can go ahead and export this out to a brand new model, and that will bring into, so when I bring that into Civil 3D, I will only have those points where I can create my surface, instead of making, because the last thing you want to do is make a surface out of 16 million points. Your computer will catch on fire and it'll make you cry. All right, to the next slide here. That was visualization editing. So now we're going to talk about scan data in Autodesk Civil 3D and AutoCAD. So I've gone through ReCap. I've clipped out the data I wanted. I want to go ahead and bring that data in. So I can import that ReCap scan directly into Civil 3D or plain AutoCAD or any of the AutoCAD vertical systems. The RCP file comes in as an external XREF file, which means in order for it to scale properly, you must set your AutoCAD units using the units command. You can set your Civil 3D coordinate system as you normally would, but it has no effect on the point cloud, only the AutoCAD unit system. So I get complaints of people saying, hey, my ReCap point cloud doesn't come into Civil 3D properly. It's because they didn't set their AutoCAD units. Feet in AutoCAD is international feet by default. You must select US survey feet if you want that to be converted from meters properly. We're going to cut sections or slices, trace polylines or 3D polys in AutoCAD or Civil 3D, and we're going to create a surface in the point cloud from those decimated points. That keeps it manageable. There are features in the Autodesk Construction Cloud for feature extraction, which I'll show next. So ReCap data in Civil 3D and AutoCAD, we're going to go ahead and start that. So we're going to go ahead and set our units command. Again, UNITS, and we're going to change this from international feet to US survey feet, because no matter what coordinate system you set in ReCap, those units are going to be metric, okay? We're going to come here to the Insert tab and go to the Attach. We're going to attach that point cloud directly in. I'm going to choose my full ReCap file that I've clipped out. And you can see as I show details, again, the point cloud is in meters, but the AutoCAD units in survey feet, so it will convert properly. There's my point cloud in, and to make it a little bit easier for me, I'm going to go to my viewport configuration, and I'm going to set up both a plan view and an isometric view. The same visualization styles that I showed in ReCap are also available. When you select the point cloud, you'll get your contextual ribbon, and you can see I can choose by object color, intensity values, elevation model, as well as those classification tools that we saw earlier. Now we're going to go ahead and use a section plane tool. So if I wanted to section in and get a building outline for my CAD drawing, I can go ahead and run what's called a live section. I can select that section and use what's called the 3D gizmo. There's a rotate, a move, and a scale gizmo. We're going to go ahead and set that down. It kind of works like a limit box, in which case anything below that section is available. And then I can turn that into what's called a slice and give it a thickness of maybe 1/2 foot thick. This gives me a nice building outline that I can go ahead and use a polyline tool to trace. So if I change that to an elevation where I got a standard colorization, makes it easier for me to see. Start a polyline tool, and then to my best of my ability, I'm going to use the 3D object snap. So just like your regular running object snap, there's a 3D object snap that lets you snap to the node of any point of that point cloud. Once I get my polyline in, I'm going to go ahead and import that decimated model. So now I'm going to go ahead and create a surface from this point cloud. You can see the decimated point cloud that comes in. There's only 68,000 points. Choose the create surface from point cloud. Once selecting that, you're going to give it a name like you would give any other normal surface, in the case called this EG surface. Change it the style to whatever Civil 3D surface style that you want. And then you can further decimate the points if you want to. I'm going to pause this slide here as well. If I did not do the ground classification in Autodesk ReCap or get a ground classified a decimated point cloud from TBC, Civil 3D does have a filtering method as well built into it, similar to what you would get for the ground classification, where I can do a planar or curving interpolation. But because we used ReCap Pro to classify our ground or decimate those points, in this point, I'm just going to go ahead and went ahead. It's twice I've done that. We're just going to go ahead and use the, there we go. We're just going to go ahead and use the standard classification. Let's go ahead and play on that. So it's going to run in the background. It's the nice thing about this tool. You can go ahead and work on other drawings as long as you don't quit Civil 3D. And it will create that surface in the background. You can see I get a nice surface available. It's not as nice as I would get normally, like I don't have that path. So I'm going to have to supplement that with feature lines for that, that sidewalk. There's other tools that you can use outside of this to assist with that, but we're going to go ahead and show you in the Construction Cloud. Here I'm going to take that building outline, that polyline, and even though it's not at the elevation, I can go ahead and create a feature line later and drape that on the surface, but I can use that to act as a hide boundary to clip that surface out of there. Then we're going to talk about ReCap of the Autodesk Construction Cloud. So what is the Autodesk Construction Cloud? It's similar to what you would see with Trimble Connect. You can upload data, including AutoCAD drawings, Civil 3D drawings, Revit models, use it as a basis to hold those models. So if I'm collaborating amongst intra-office or multiple offices, I'm working on Civil 3D or Revit, I can actually host those files in the cloud, open them and work on them and file lock them from the cloud, use Sheet Set Manager in the cloud, print and publish in the cloud, and maintain everything up there. So everybody, no matter where you are, every time you open up a drawing or model, you're always getting the same one. You don't have to worry about opening up a bad version that's like 2 days ago. Share your model among project stakeholders and extract point and feature data for your other products like Civil 3D and Revit. So in this little video here, I'm going to go ahead and it's easy in ReCap Pro. All we have to do is click the button that says, hey, I like this model. I want to publish it to the cloud for use. I'm going to use the Autodesk Desktop Connector, which acts as the go-between between my desktop and the Autodesk Docs, which is the Autodesk Construction Cloud. I choose a folder, the project I want it to be in, and the folder I want it to go to. Say select, and all I have to do is hit publish. And ReCap Pro takes care of everything. Once we're on the web browser, so this is in Google Chrome here, I can also manually upload files, but there's that point cloud I just opened. Click on the RCP file and it will open up this point cloud in the Autodesk Construction Cloud. So anybody who doesn't have the program can come in here if you share this link. And similar tools or rotations, I can change visualization styles as well as publish and share. So I can share this model out either with other project members who haven't seen this or by a generated link. And if I did get that link and I didn't have the file, I can use the Construction Cloud to download this directly to my computer. Okay. It has some basic measurement and dimensioning tools. These become annotations inside, just like you can in ReCap. And then I can turn those on and off as need be as well. All right, moving on to the next section now, I'm going to switch over to that same model that Greg used previously for his feature extraction. There are feature extraction tools inside the Construction Cloud as well. I'm going to zoom in on the same stretch of curb. It's kind of funny. I'm going to go the opposite way. I'm going to change a couple things. I like to work in intensity mode because it lets me see the difference in materials and makes it easier for me to see where the pavement and the curb, especially if they're similar to the same color. And I'll change the point size up a little bit. Now, the features we can extract are linear and point, as well as other 3D objects. Similar to what Greg showed in TBC, I start with a template, select a dimension, I get that cross-section view, and then I can go ahead and set those nodes. I make as many multiple nodes as I want to. I can delete nodes. And once I get a section I like, I can go ahead and save that as a template for this project. So next time I go ahead to create a feature extraction on the remainder of the curbs in the site, I could just pull that model up instead of having to remake that. The settings that I'm going to set would be tolerances. So it's going to check that threshold that it deviates from that section, as well as my forward step in the section view depth. I can manually go ahead and click each link to extract, or I can press the automated extract button and it will start the automatic extraction, checking that tolerance in the upper right corner of that section view, as you see as it runs along. When it reaches a point that it can't continue anymore, it'll allow you to change the section and or go ahead and modify that section for that curve. We also have point. Now, this isn't automated, unfortunately. This is still all manual. So if I wanted to extract a point for this light, I would choose the feature template, place the elevation next to it, and use the cross-section view to place that point right in the middle of that concrete base. Could do that again with the trees. So all these feature templates, when these get exported out, I can export these feature lines and points as a DXF file or LandXML or as reshape file. And those attributes of whatever you see there in that point list library will be the description. So if I export it as a CSV, I'm going to bring that in as a COGA point. And if I have my descriptor key set up in Civil 3D Survey Database, they will show up in the proper point style that I like. Here you see I'm doing something new that just came out in this version of ReCap on the cloud is the sidewalk ramp extractor. So it's going to make a series of feature lines to extract any kind of handicap ramp. I'm kind of guessing here on this one, but I'm going to stretch this all the way across. These would be feature lines and points that get exported out, as well as the ability just to create some basic, I'll skip ahead a little bit, create some basic line work, like for backup line, any kind of 3D object that is not going to be collected in a normal fashion with that extraction. Last thing I'm going to show you here is scan and Revit. I'm going to quickly, only got a minute or so left here, so I'm not a Revit guy. Revit is used for creating 3D models, BIM models for existing or proposed conditions. I can align the point cloud into Revit, similar to I can in Civil 3D. I can create model objects as needed from that point cloud or use it as the basis to make new data to tie into an existing building. I'll go through this very, very quickly. Really close on my time here. I've gone a little bit over. You would bring your point cloud in. The interesting thing about Revit is because of the way Revit models work, you have the levels for first floor, second floor, third floor. You define the base and the ceiling elevation. It automatically clips that point cloud for you to that ground and base. So I'm looking at a section of that first floor model, using it to align in there. I'll just go ahead and move on to the next section. and then I can use the point cloud to either draw walls in here using the Revit 3D wall models, as well as, let me skip ahead a little bit, adding items like windows, aligning them up with point cloud to create my model. I'm not a Revit guy, so my models are very rudimentary. We'll move over here to a 3D view. So this is a 3D view in Revit. You can see how I'm starting to manufacture, starting to create my model based upon that point cloud. Again, I don't have to use it for creating existing models. If I was to build an annex or a garage or something and I wanted to tie it into this building, I can use it as my tie point and just as a plane of reference. And that's all I got. So summary, Autodesk ReCap Pro has really evolved. If you've used it in the past and were disappointed with it, keep in mind they're offering new tools. Autodesk has realized they really need to move the bar up on their ReCap and their point cloud solutions. That's all I've got. And that's it. We have some questions here.
It looks like we had one in the question section of the, the question was how well does the automatic classification work for UAS collected point clouds? And I'm guessing that's in TBC. That
Yes.
was improved in 2024. So in the previous versions, the photogrammetry and the UAS data only had like 5 regions, kind of like what TBC was when it first came out. But I believe it's in 2024. Where now it works the same way that it does for the terrestrial point cloud. So you get those, I think it's about a dozen regions. And as far as the colorized or non-colorized, the TBC's always been good at region classification, whether the data is colorized or non-colorized. I would guess that some of the newer algorithms with the deep learning might use some of the colorization. So, but I haven't seen any issues with that so far.
One of the things, Greg, I really did like about TBC too, that when dealing with photogrammetry, you don't have those intensity values. Like I say, I like to use, when you bring your photogrammetry colorized point cloud into TBC, it does kind of assign a quasi-pseudo intensity values based upon those colors and lets you see those. So it makes it a little easier because you can use that combined elevation and intensity model even on photogrammetry.
Yeah. Does anyone have any other questions? Go ahead and enter them into the chat or the question section there. What do we got here? Oh, there's one for what type of point does TBC extract for Civil 3D? Well, you can do CSVs or all the normal formats. I think you can even export those points as a DXF if you'd like. So those are pretty much the typical formats you'd use.
The most common we would use in Civil 3D from TBC would be those CSV files. So using those point extraction and the manhole extraction tools, when you can either export the drawing out if you're not worried about those COGA points, but if you really need those COGA points for some function like for making pipe networks or something, I would expect a CSV would be the best.
Okay. Yeah. Especially if we're using the feature codes, correct?
Yes.
Yeah. Okay. I gotta look at some of that Revit stuff. That was pretty cool, actually.
One of these days, I'll learn it.
Yeah. Okay, here's another one. We got a couple more coming in. When exporting out from TBC and importing into ReCap, do your regions come in, or do you have to reclassify? There's 2 RCP exports. I should open up TBC real quick. I believe there's a way to do that. I haven't done the RCP export in a while.
It depends when you export an RCP. So I got one at multiple scan stations. There are 2 types of RCP exports. There's RCP, which would give you a unified point cloud. All you have to do is open it up in ReCap directly, and there she is. Or you can do it with scan stations. So if you want those bubble views, you got to export those out as ReCap. ReCap is not as forgiving as TBC though. So if you don't have, you really need that 20 to 30% overlap between your stations. Because if you don't, no matter what, there are going to be unregistered stations, and it'll try to auto-register things. It's going to go into that mode where you're going to have to manually register the remaining stations. And sometimes it's only 2 or 3, sometimes it's a dozen, and it takes a little bit of time. The same thing with E57. You can export E57 in both sessions as well.
Okay, the next question is, what about scan noise? So I'm guessing that's for like noisy point clouds. One of the things I've been doing lately is with Sight Vision and iPhone LiDAR, and that is a noisy point cloud. And the advanced filtering, especially for ground, and I should kind of iterate that that's for the ground mainly, the advanced filtering right now. But we can basically take an average of that noise or a minimum elevation of that noise or a maximum, depending on what we're scanning. Like I was scanning bare ground, so I took the minimum elevation and created a surface it filtered out all the noise above the minimum points. I guess it depends on what you're scanning, but yeah, there's some of that. I don't know what ReCap has, but
yeah, there's not much of the noise filtering on the ReCap size. It doesn't have that. I'm typically using that in something like Pix4D Surveyor or other tools that allow that. Yeah, in ReCap I'm using limit box, just deleting points, putting them on a noise layer manually.
Okay. Next question, how does registration handle moving objects? So I'm guessing that's probably cars. Would you agree, Mark?
Yeah, the ground classification with like cars and moving vehicles is typically handled as a statistical model. So it's, when the ground classification, at least on the ReCap side of it, it's making tiny meshes. A lot of programs work this way. They're making small mesh models, and they're checking the average slope of the triangles for those meshes, and if they deviate by more than a certain percentage of or a certain degree, it kicks those out. So something like a vehicle that has even if it's a trail that has a vertical wall to it, it does a pretty good job at kicking those out. The same thing with cars and static vehicles like that.
Yeah, I know like RealWorks has some tools for that. We didn't even talk about Trimble RealWorks today, but it does have algorithms for moving objects, either for registration or classification as well. Yeah, I mean that's part of your quality control process too. We may have to, if there's a lot of those, and I mean algorithms aren't perfect. At least they aren't yet. So we may just have to manually deal with that, whether it's registration or region classification. Okay, the next question here, are there any more auto registration features planned for the future of TBC? So I'm thinking I think we're talking about the registering the clouds together. I mean, they haven't really said anything to me yet. I haven't heard. There's right now the typical tools. If and this is Robert's question, if they're talking about the region classification, yeah, I would probably think there will be at some point. Automatic point registration.
That moving trees question, that's also a moving trees hamper scan registration. That's also an issue for us doing UAV photogrammetry. Anywhere you have trees and in the wind, you'll end up with big blank spots in the point cloud.
Yeah, I'd have to get back to the question on the, and that's Rob, I'm gonna write that down. Robert, on the auto registration. Yeah, they're pretty tight-lipped on what they share with us. If it's not, if something's in development, so it's meant automatically. Yeah. So yeah, we'll have to get back to you. And then Cyclone 3DR or TBC, is that related to one of the previous questions? I mean, obviously, I'm going to say TBC.
Yeah, right.
Yeah, and we'll wait a couple more minutes for questions, but I mean, so again, today was a brief overview of things that are in the Trimble and Autodesk products. We're just today was really to inform you. What we'd like to do is hear from you, what you'd want to see in a future webinar, like the registration or grid to ground is going to be a popular one and kind of contentious one. I think it's something we'll have to tackle at some point. yeah, we're kind of looking for ideas on what you all want to see, and we can certainly do, well, anything you saw today we could expand on. I mean, a lot of those topics we probably typically spend at least an hour on. We had kind of a few minutes for each one, so I'll type my email into the chat, I guess. And if you have questions for me personally, I can certainly answer that. Well, I think we'll be sending out a recording. Yep. But if there's anything you need, we can certainly contact us. And we're kind of unique in the industry in that we have Trimble and Autodesk in-house. So if you've got both softwares, we can help you kind of come up with a workflow that would work for both. There's always a jumping off point, it seems, between TBC and Autodesk. It just depends on where that jumping off point is. I mean, we could draw line work in TBC, but it's just not a popular thing that's done in TBC. But most people are exporting out and going to Civil 3D or AutoCAD at that point.
Also, if you guys have interest in other topics you'd like to see in the webinar, please go ahead and email either of us. Or
you got a problem with the TSE5, you want to call me this afternoon about it, feel free. Actually, the phone's been ringing during the presentation here. Oh, we got some more questions here. Okay. Moving old data into NSRS 2022, including for change, will be a huge issue. And I think we're all dreading that. I'm hoping that, again, Trimble and anything in development, they don't share with us unless they want feedback on it. And I think that's just kind of the big the elephant in the room that everybody's avoiding right now is the NSRS 2022. For people that have not used TBC, you can go to the Trimble Business Center website, and there are 30-day demos available. You'll have to fill out a form. Thank you, Ben, out of our Iowa office for that. It's a good reminder. And actually, even if you want to get a feel for TBC, if you download and you don't have a license, it does let you do a fair amount. You can view point clouds. You just can't do much with them. On the foot change. So Dan clarified that it was for the foot change. Again, we'll see how everyone reacts to that. And I know Trimble's got stuff ready to go. Thankfully, Michigan in our territory has been working in international feet for years. So we are used to kind of dealing with that. Well, when people are sharing data between Michigan and other states. I don't remember if there's any others in our territory that are international feet already, but there's a process. And
the AutoCAD world, we're always dealing with it because, again, that default unit out of the box is international. People don't pay attention. So
that's a big one for Autodesk. Those units aren't set right. We see shifts, and so NGS will provide transformation tools for NAD 2011 to 2022, and I'm guessing all of that stuff will be written into Autodesk and Trimble software. So it's just a matter of when it's released, and hopefully everybody gets our, honestly, there's another comment there. Meters, I mean, once you use it a little bit, it honestly, I look at all my scan registration values in millimeters, and it makes sense in that situation. But yes, using meters,
I grew up in Michigan. It was always both. We were right on the border. Mm-hmm. And back in the 90s, I think we had several DOTs that went metric, and we retooled for meters, and I kind of miss it. It was fun going to that.
Yeah, Dan's other comment there, strategies for spatial checks. Yeah, that's probably in a couple of years will be the source of a few webinars. So we'll all get there. I think we've got them all. And again, contact Mark or I, and we're coming up on the top of the hour. Oh, thank you guys. Thank you for participating, everybody. A lot to cram into an hour. I think we got it done, but we're excited to do more for you, and let us know what you want to see.
Right on, everybody. Have a wonderful day, and thank you for attending.